Thank you for your interest in string instrument physics. This video gives us an easy way to think about sympathetic vibrations. Why is it that when we play certain notes in tune, open strings vibrate, making our tone rich? Using sympathetic vibrations, we can increase our pickiness about intonation. In the revised edition of Suzuki Violin Book 2, the students work on finding what is called the point of resonance on page 9. For example, I will play a fingered D on the G string, and first I will play it out of tune, and then I will move it in tune, and as I get more and more in tune, the width of the oscillation of the open D string increases. I'll get very close to the camera. Hopefully you'll be able to see this. The sympathetic vibration of the open string happens if the note that I'm fingering has close to the same number of oscillations per second as the open string does. The number of oscillations per second is also called the hertz. Okay, so that kind of makes sense. But when I bow an A on the G string, which has 220 oscillations per second, why does the open D and the open A and the open E all ring along with that A? It's almost like they vibrate magically. In an earlier video, I talked about the fundamental and the overtones. The note I play is the fundamental, and as a bonus, these other notes ring also within that note, but we can't hear them because the fundamental is so much louder. These other notes are called the overtones. You'll also notice that these are the harmonics that come out when we play an open G. An octave above, a fifth above that, a fourth above that, a major third above that, a minor third, and another minor third. And then I wrote etc. because they continue on and on up. So when we play open G, also called G3, it is vibrating the air at 196 oscillations per second, or 196 hertz. Also, there's a G4 vibrating at 392, and a D5, and a G5, and a B5, D6, F6, etc. Let's pretend that the G3 is the parent, and it has all these kids. The overtones are its kids. So in the G3 family, we have all these kids plus a lot more, but I've notated the most important ones. We also have other open string parents and families. For example, we have the D4 family and the A4 family and the E5 family. Let's go back to my question. If I play my first finger on the G string, A3, and it vibrates at 220 oscillations per second, why does the A string and the E string and the D string, why do they all vibrate sympathetically? None of them have 220 oscillations per second. Are any of the kids in the A3 family friends with any of the kids or the parents in any of the open string families? In other words, do any of the A3 overtones match any of the overtones or fundamentals of the other open strings? When kids are friends, don't the parents need to talk to each other? And the equivalent of parents talking to each other are the sympathetic vibrations. So let's take this A, first finger on the G string, A3 family, and let's see if any of the kids in this family are playing with any of the kids in the D string family or the A string family or the E string family. Okay, so let's look here. We have an A4, 440, no A4 here. How about an E5? Nope, no E5. How about an A5 that oscillates at 880 per second? Ah, here's an A5. Let's put a check mark on those. So those two overtones are vibrating together, which means that the parent, the D4, and the A3, they'll have to chat with each other if their kids are playing together. Therefore, the D4 will be vibrating as a sympathetic vibration. Now let's check to see if any of the A3's kids are vibrating with any of the A4's family. So, oh wow, look right away, we have the youngest kid is going to be at A4, and that's 440, and the fundamental, the parent of this one, is vibrating at 440. Okay, let's keep going. Is there an E5 in this group? No E5. How about an A5 at 880? Yes. A5 at 880. So far, 2 kids are talking together. 2 pairs of kids. Now, is there a C sharp 6? No, but how about an E6 at 1,318 oscillations per second? Right there. This is a strong connection between the first finger on the G string and all the notes in the A4 family, in the open string family. So this open A string is going to vibrate very, very fat, because that's a lot of connection between the overtones of the A3 and the overtones of the A4. Let's check out to see which members of the A3 family are hanging out with or chatting with or playing with the members of the E5 family. So not A3, there's no A3 here, there's no A4 here. How about E5? Right here we have an E5. So the second to youngest child in the A3 family is talking to the parent of the E5 family. So let's keep going up here. No A5, no C sharp. Oh, but look, we have an E6 and an E6. Both of these have the same 1,318 oscillations per second. So they are sympathetically vibrating each other. So this, between the A3 family and the E5 family, there are 2 connections. This one and this one. So that's quite a strong sympathetic vibration for the open E string when we're playing A3. To summarize, as in the example of Suzuki page 9, we will get the fattest and most obvious sympathetic vibration of an open string if we play a fingered note that is the exact same note as the open string. For example, if I play this D, say with a pinky, my open D will have a whole lot of vibration on its own. We will also get a fat sympathetic vibration if we play a fingered note an octave away from an open string. So if I played this D up here with a finger, this D would still ring. Or if I play this A down here with my finger, this open A will still have a sympathetic vibration. Even cooler than sympathetic vibrations between notes that share the same name, we also have sympathetic vibrations, as we can see from this chart, from notes that do not have the same name. I play an A, my E string rings. I play an A, my D string rings. Because the overtones of these various notes are communicating with each other and getting the fundamentals to ring. To simplify the search for the sympathetic vibrations, we can ask ourselves 3 questions. The first is there an open string that has the same letter name as the note that I'm playing? If so, then that open string will vibrate sympathetically. Question number 2 is there an open string that is a perfect fifth away from the note I'm playing? For example, if I were playing this A, I could count on my fingers up to 5, counting the note A. A, B, C, D, E. Yes, there's an open E string. That's going to work. How about the third question? That is there an open string that is a perfect fourth away from the note I'm playing? So if I'm playing this A, I can count A, B, C, D. Is there a D string, open D string? There is. So that's why all 3 of those notes will be ringing. Let's say that I'm fingering an A on the A string, let's say 5th position up on the A string. So my A string, open A string, will not be able to ring. So let's count up from A. a fifth. A, B, C, D, E. My E string should be ringing if I'm in tune. I'm wondering if you can hear me tapping the E string. It's stopping its oscillation, so we can tell that it's vibrating on its own. And the D string should be ringing, because if we count up A, B, C, D, that's 4 notes. Can you hear that tapping? I'll play out of tune now and I'll do the same tapping. We don't hear anything, I'll go in tune. Now I can hear the tapping. This is a really good way for more advanced students to practice getting their higher position notes in tune, to check the open string oscillations of the sympathetic vibrations. I think it is so wonderful that string players have a built-in intonation training system through use of the sympathetic vibrations. Thank you for watching this video on sympathetic vibrations, and may your overtones play together always.